Welcome to our MCHE 3920 manufacturing project video presentation. For our project, we designed a park bench with a reversible seat so that benches being made unusable because of rain can be a thing of the past. This video will demonstrate the processes involved in production of a functional small-scale version of this bench. Our group members are Cody Lepage, Kendall Kelley, Grant Gibson, Aaron Kitchens, and Logan Davisson.
Much like many brilliant ideas, this idea came to our heads while we were at the bar. Once we left that atmosphere, we took this idea and made a quick napkin drawing. This allowed us to put our thoughts on paper and let us better visualize what we were about to do. I then took these quick sketches in the Fusion 360 and made a design that was functional and needed to have correct orientation with gears and the seat. Once this was accomplished, I sent the drawings of the left and right main frame, the bottom and back of the seat slats, as well as all of the gears, the pole arm. I sent them all to become STL files, where I would open them in an STL file reader in G-Code Maker, Simplify 3D. Once I configured what I wanted my settings to be from the 3D printer, I saved them as a G-Code, and then I sent those files over to my 3D printer. Once all the parts were finally printed out, we could finally assemble them into a functioning prototype. I needed to design and print out a very accurate negative mold that we would fill with the silicone. As you can see in the video, the gray color would be the 3D print, while the cream color shows the new silicone mold, and when it flips over, you'll be able to see exactly what the silicone mold looks like on the inside.
After 3D printing our mold negatives, the next step was mixing our silicone compound and pouring it into the printed negatives. After pouring, we agitated the silicone to facilitate any trapped air to rise and escape. The silicone compound then took roughly 90 minutes to fully solidify.
After solidifying, we then had to remove the finished molds from the printed negatives. We were very careful here as not to damage the molds during the removal process. After removal, we could fully assemble them, making them ready for casting. After this, the next step was to melt down our raw metal in preparation for casting. The metal used in a tin bismuth alloy with a relatively low melting point, which allowed us to use a gas grill to melt it. We then proceeded on to casting and poured the metal into the silicone molds. The molds were preheated to eliminate moisture and prevent vapor explosions.
After allowing sufficient time for the metal to solidify, we then removed the casted pieces from the molds, and basically they were now finished and ready for further assembly with our non-casted parts.
Now we're going to finally assemble the completed prototype, as well as go over the lessons that we've learned through this entire project.
This project allowed us to gain real-life experience of the manufacturing design process, specifically when working with 3D printing, molding, and casting. We were quickly reminded of how important it is to be willing to go back to the drawing board, as we had to make several iterations of our bench before we reached the final product. It was also determined that 3D printing has a much greater tolerance than we expected. We think this could be attributed to the temperature of the extrusion speed, z-axis wobble, and the type of filament, to name a few. When designing multiple interlocking gears, understanding the tooth-to-size ratio of various gears can be a complicated process, becoming more complicated the more gears you add. It's important to focus on the speeds at which each gear turns because it changes with size, in order to make a properly functioning system. Finally, in the process of making the negative molds to create silicone molds, we had to take our time to fully conceptualize the depth of the mold in addition to the creation of a top and bottom as we were making a two-piece mold. We learned a lot of lessons throughout this entire project. Thank you so much for your attention, and we hope you enjoyed.